to another episode of Mr. Jacobson's Chemistry podcast. And what I'm going to be talking about today is for physical science. We're going to be talking about how to figure out why atoms bond. Because one of the questions I always have is, why do atoms want to bond together? What causes them to bond? Well, if we look here at the periodic table, we're going to be using the periodic table so many times for so many different things. But if we look here, we see that we have hydrogen. We're going to just start talking with hydrogen because it's the simplest atom on the periodic table, and we're going to just bother with him for right now. We look at hydrogen, we see that it has the atomic number 1 right up at the top. That means that it has 1 proton, and since atoms on the periodic table are neutral, that tells us also that it has 1 electron. Well, let's draw a model of hydrogen because I always like to visualize things. We have hydrogen, there's the symbol for hydrogen. If I were to draw the Bohr model for hydrogen, I'm going to put 1 proton in the middle because there was 1 atomic number on the periodic table here. That number 1 tells me I have 1 proton, red dot. And then I'm going to put electrons outside of that proton. Okay. A lot of times we use rings. This represents what we call the electron cloud. And this is called the Bohr model whenever we use rings. Now, since it has 1 proton and things on the periodic table are neutral, we know that, well, protons are positive. So if we have plus 1 and we want it to be 0, well, plus 1 plus what equals 0? Well, plus minus 1. So we know that electrons, we need 1 electron because each electron is negative, and we want to equal 0 from the periodic table. So we're going to put in 1 electron onto that ring. Okay, so we have our Bohr model of hydrogen. Well, hydrogen isn't happy with just 1 electron. It's what we say is very reactive. It's a highly reactive element. If it just has its hydrogen by itself, it's not happy, it's not stable. Well, how do we get it to be stable? The way that we get it to be stable is we want to fill up its energy level. Its outermost energy level always wants to be full for it to be stable. Next question is, what would make it to be full? Well, the first energy level, the lowest one, the most simple one, is going to have 2 electrons in it. And we've learned that after 2, then we have 8, and then 18. Well, actually, to make it a little bit simpler, we're just going to say everything after 8 is always 8. From that point on, all of the rest of the levels are going to be 8. It's called the octet rule. And the octet rule, O-C-T-E-T, octet, says that other than this first energy level, all of the rest of the main group elements want to have 8 electrons in its outer ring. This one has, well, this is hydrogen, it only wants 2. And so it's going to get another electron from somewhere. Now, if it was a really strong element in terms of electronegativity, which is a chemistry concept and not something you have to know for physical science, then it would just be able to tear one off and steal it from another atom. Well, it's not strong, and so it can't do that. It can't just tear it off of another atom. So it has to do, usually, it has to share electrons with something else. Well, what's something else that it would want to share with? How about another hydrogen? If we have another hydrogen here, how many outer electrons did that hydrogen have? Well, it had 1. So it has 1 proton, and then we draw another ring around it, and we have another electron here. Now, we have 1 there, 1 electron here. It wants to share, and it's happy with 2. And so what's going to happen is this is going to get used by this hydrogen, this one is going to get used by this hydrogen, and they're going to end up making a bond by sharing this pair of electrons right here. And so they're held tightly together. The way that we represent a bond is the symbols with a dash and then another symbol. And so we'd say that this was hydrogen bonded to hydrogen, or if we wanted to write it in a formula, we would call it H2. Okay, where this is the subscript saying that we have 2 hydrogens that are both bonded together. And the reason they're bonded together is so that they can be stable and so that they have the number of electrons that they want in their outer level. If it was a bigger atom, it would want 8 instead of 2. Anything on the periodic table down here